Hi everyone, welcome to my channel Icon Teacher. I am Satya Prasad. In this session, we will discuss the concept of subsets. Well, this is a very simple concept. Let us consider set X to be the collection of all the students of your school, and let Y be the collection of all the students of your class. We observe that all the elements of Y are in set X also, because all the students of your class are the students of your school. So, in such case, we call Y is a subset of X. So, let us see the definition. A set A is said to be subset of B if every element of A is also an element of B. In other words, we write if A is subset of B, if whenever small a belongs to capital A, then A also belongs to B. So, we write it as A is a subset of B if A belongs to B implies A belongs to B. So, here we use the symbol to denote the subset. So, this is a symbol used for subset. So, A is a subset of B. So, this is the symbol we use for subset. Well, suppose if A is not a subset of B, then we use the symbol not a subset, just like how we use for not equal to, we put equal to with a slash. In the same way, if you want to say it is not a subset, we put subset with a slash. So, this is the symbol we are going to use for not a subset. So, we read it as if A is subset of B, if A is an element of A implies that A is also element of B, and if A is not a subset of B, then we write A subset with a slash, which means it is not a subset of B. What if A is not a subset of B? How do we know that A is not a subset of B? So, if you want to say that A is not a subset of B, we use the symbol subset with slash, and that is called not a subset. So, if all the elements of A are not in B, then we write A is not a subset of B. So, if all the elements of A are not in set B, then we say that A is not a subset of B, not a subset of B. So, we use the symbol null set, the subset with a slash, to show that it is a not a subset. So, this is symbol we are going to use for not a subset. So, I hope you understood what is not a subset. So, we have seen what is a subset and what is not a subset. Let us take a simple example. Say A equal to 1, 2, 3, and set B contains 1, 2, and set C contains 1, 5. So, if you observe the set B, all the elements of B are in A. So, we can say that B is a subset of A. Whereas, if you observe the set C, all the elements of C are not in A. You observe that 1 is in A, but 5 does not belong to A. So, we say that 5 belongs to C, but 5 does not belong to A. Therefore, C is not a subset of A. So, we use the symbol not a subset in this case. And here if you observe the set B, all the elements of B are present in set A. So, we use the symbol is a subset of. So, B is a subset of A, and we observe that C is not a subset of A. Let us see what do we call B if A is a subset of B. If A is a subset of B, then B is called superset of A. So, the symbol for superset is the mirror image of the subset. The symbol just looks like a mirror image of subset. So, this is called a superset. So, if A is a subset of B, then we say B is a superset of A. I hope you understood what is a superset. Well, now let us see the different subsets which we have already seen in the different types of numbers. So if you see the different numbers, all the natural numbers are in whole number set. Therefore, we can say natural number set is a subset of whole number set. And if you could see, the complete whole numbers are in the collection of integers. So we can say that whole number set is a subset of integers. Similarly, if we see the integers, the complete collection of integers are in the set of rational numbers. So we can say that integers is a subset of the rational numbers. In fact, all these rational numbers are subsets of the real number. So we say that natural number set is a subset of whole number set. Whole number set is subset of integers. Integer set is a subset of rational numbers, and rational number set is subset of the real numbers. Now those numbers which are not rational numbers are called irrational numbers. So let us represent that with T. So the green shaded region which you could see is the region where we have irrational numbers. So all the rational numbers and irrational numbers together are total real numbers. So here we could see that n is a subset of real numbers. N is a subset of real numbers. And then also I can say n is a subset of rational numbers. And if I want to say n and t relation, what can we say about it? Is n a subset of the irrational numbers? No, because t stands for irrational numbers, and we can say that n is not a subset of irrational numbers. N is only a subset of rational numbers. We could see that n is not a subset of the irrational numbers. So n does not belong to, or n is not a subset to t, is what we are going to say. So clearly we could observe that n is a subset of z, z is a subset of q, q is a subset of r, t is a subset of r, and n does not belong to t. So let us discuss about what are irrational numbers. If you want to write the collection of irrational numbers, we can write it as the set of all x such that x belongs to r and x does not belong to q, because we say that real numbers are the collection of total rational numbers and irrational numbers. So if the number is not rational, then obviously it is a irrational number. So we can write it as the set of all x, x belongs to r and x does not belong to q, which means it is a collection of irrational numbers. Now let us discuss what is a proper subset. So we have seen in the subset that if all the elements of A are in B, then we say that A is a subset of B. Now let us focus on the superset. If the superset contains at least one element more than the subset, then we call such a subset as a proper subset. So if A is a subset of B and A is not equal to B, then we say that A is a proper subset of B. Now let us see how to write this definition. Let us write down proper subset. If A and B are two sets such that A is subset of B and A is not equal to B, then A is called the proper subset of B. So if in such case the only set which is not a proper subset is the set itself. Okay, so if you are asked what is the subset which is not a proper subset, then we can say the set itself, and such a set is called as improper subset. So the set itself is, which is a subset of the set, is called an improper subset. So we have seen what is a proper subset and what is an improper subset. Now let us see what is a proper subset and what is an improper subset with a small example. So let us consider set A is equal to say 1, 2 and 3, and set B is equal to 1, 2, and set C containing 1, 2, 3. So here if you observe, all the elements of set B are in set A. So we say that B is a subset of A, obvious. Now also we could observe that the number of elements in set B is less than the number of elements in set A. Therefore we say that B is a proper subset of A. So we use here proper subset. Proper subset. Now let us observe C. All the elements of C are in set A. So obviously again C is a subset of A. But here we observe that all the elements of C are in A and also all the elements of A are in C. Therefore this is the set which is called as an improper subset. So here n of C is exactly equal to n of A. So here we don't say that C is a proper subset of A, instead we say C is an improper subset of A. So we write it as C with the symbol subset with equal to, and we write it C is an improper subset of A. So as we have discussed that every set which is a subset of itself is an improper subset. So in this example we could observe that C is an improper subset of A because it contains all the elements of A, and also you observe that A contains all the elements of C. So this gives us another important aspect, that if A is a subset of B and B is a subset of A, then A is equal to B. So we can also write a result that if A is a subset of B and B is a subset of A, then A is equal to B. I hope you understood. Let us see some important results of subsets. We know that all the elements of A are found in set A. So A is a subset of A, which means every set is a subset of itself. As we have already discussed that this will be an improper subset. And since null set does not contain any elements, the null set can be considered as a subset of any non-empty set, and in fact it is a subset to itself also. So null set is a subset of every set. So we have to draw a conclusion that every set is a subset of itself and null set is a subset of every set. So that is the first point. Every set is a subset of itself. Then the second point to be noted is that empty set phi is a subset of every set, and the third point is if A is a subset of B and B is a subset of A, then A is equal to B. So in fact if you want to prove that two sets A and B are equal, we have to prove that A is a subset of B and B is a subset of A. Then the third point is if a set A has n elements, then the number of subsets equal to 2 to the power of n. So that is also a very important result. If set A has n elements, then the number of subsets equal to 2 to the power of n. And the empty set phi has only one subset, that is null set itself. So let us try to observe this set. We know that null set is having no elements. So the number of elements in null set is 0. So as per the formula, the number of subsets is 2 to the power of n. So the number of subsets of null set will be 2 to the power of 0, that is equal to 1. That means there is only one subset of null set, which is the set itself, that is null set. So the subset of null set is the null set itself. Now let us see the important notes. The first point, every set A is not a proper subset of A, it is an improper subset of A. That is the first point to be noted. And the second point, every non-empty set has minimum two sets, that is the set itself and the null set, whereas in the case of null set we have only one subset. Then an element cannot be a subset, that is A is a subset of A comma B in braces is an incorrect statement. So the correct symbol should be A belongs to A comma B, and also suppose we write A in braces, so which is a subset of A comma B. So this is how we are supposed to write. So if you want to write A is a subset of A comma B, if A is written in braces, then we can consider this to be a subset. So this is a correct statement, and A belongs to A comma B is a correct statement. So this is how we are going to do the presentation of the right symbol when we are writing down the set which contains AB, and if you want to write A is a member of the set containing AB, so we write A belongs to A comma B in braces. This is correct. Or if you want to make use of the symbol subset, then A within braces is a subset of the set containing AB. Okay. Now let us see a small example how to write the subsets. So if A is equal to 1 comma 2 comma 3, write all the subsets of A. So let us write down the different subsets of A. Subsets of A. So we know that null set is a subset of every set. So the first subset is null set. Then we have singleton sets, that is set containing 1, then set containing element 2, then set containing element 3, then set containing 2 elements, that is 1 comma 2, then set containing 2 comma 3, then set containing 1 comma 3, and the complete set itself, that is 1 comma 2 comma 3. So as per the formula, the number of subsets is given by 2 to the power of n. Here the number of elements are 3. So since n of A is equal to 3, we get the number of subsets to be 2 to the power of 3, that is equal to 8. So number of subsets of A equal to 2 to the power of cardinal number of set A, that is 2 power 3, that is equal to 8. So if we count them, we get null set. Singleton sets are 3 in number. Then we have set containing 1 2, 2 3, 1 3 and 1 2 3. So in total we have 1 2 3 4 5 6 7 8. So we got totally 8 subsets. Now as we have seen that the only subset which is not a proper subset is the set itself. So if we are asked find the number of improper subsets, so we can write number of improper subsets of A. The answer is 1. There is only one improper subset, which is the set itself. So number of proper subsets equal to, so we have to subtract 1 from the total number of subsets, that is 2 to the power of n of A minus 1, that is 8 minus 1, that is equal to 7. So in this example we have totally 7 number of proper subsets. Let us see the second example. Write all the subsets of the set containing null set. So here we observe that there is one member in the set. So here if you observe, the number of elements in this set is one element. So let us consider A as set containing null set. So n of A is equal to 1. There is one member in this set A, that is null set. So number of subsets will be equal to 2 to the power of 1, that is equal to 2. So the number of subsets are 2. Now let us write down what are these subsets. So the subsets are one is the null set and the set A itself, that is set containing null set. So these are the two subsets. Another problem, true or false. You are given set A is null set containing 1 comma 2, 3 and 4, and the first question asked is we have to say whether it is true or false. Null set is a subset of A. First of all, let us have a quick recap of what is a subset and what is the meaning of is a member. Suppose we have any set which contains some members, then we must write member belongs to A and member in braces is a subset of A. It is as simple. The thumb rule is this: when a set contains members, member belongs to A and member in braces is always a subset of A. So any number of members, if you put in braces, then it is a subset of the given set A. So based on this simple logic, let's try to answer these questions. Null set is a subset of A. We know that null set is a subset of every set. So the answer is true. So the answer is true for this. Next, null set belongs to A. So here we could see that set A contains 4 members. The four members are null set, then set containing 1, 2 and set the element 3 and then the 4. So it has 4 members, null set containing 1, 2, 3 and 4. So totally we have 4 members. So here we could observe that null set is also a member of set A. So null set belongs to A is true. So we have to write this answer as true. So this is true. Then the number of elements in set A is equal to 4. So we could clearly see that there are 4 members. So the answer is n of A equal to 4 is true. Right. Then 1 belongs to A. Is 1 a member of A? Belongs to matlab member. So is 1 a member of A? So here we could observe that there is no member which is 1. It is a member which is 1, 2 in braces. Therefore 1 belongs to A is false, because there is no member with 1 as an element in set A. So 1 is not a member of set A. So we write 1 is not a member of set A. So 1 belongs to A is false. Then set containing 1, 2 is a subset of A, and here we could clearly see that 1, 2 in braces is a member of A but not a subset of A. So it is false. Right. Set containing 1, 2 is a member of A. Belongs to A means it is a member of A. So this is true. Then 3 is a subset of A. So 3 is a member of A but not a subset. So this is false. And then 3 belongs to A. 3 is a member of A. So 3 belongs to A is true. Now let us see the second last one. The set 1, 2 within braces. So the member in braces is a subset of A. So obviously this is true. And then set containing 2 members, that is null set and 3. So these are the 2 members of set A. So I have written 2 members separated by a comma within the braces. Obviously it is a subset of A. So this is also true. I hope you understood the concept. So if you like my video, please like, share and subscribe to my channel. Thank you.